Hello everyone, welcome to our presentation. My name is Khalfan and my colleague's name is Rizwan Mustafa, and today we will be presenting you our rehabilitation clinic design based in Philadelphia, USA. This slide shows you the table of content. We have two parts. On the left side will be the building and the kinetic concept, which will include the site analysis of the location, the climate data of the location, how we came up with the kinetic facade, its concept, the sustainable strategies to improve the design, the building codes which were followed for the Philadelphia, USA, building plan and the envelope. On the right side, we perform the IES analysis, which includes the optimum orientation, the sun cast, thermal analysis based on the three seasons, as well as daylighting analysis. Site analysis. The site was chosen in Collingdale, Philadelphia, Pennsylvania, USA. It was chosen there as in when the climate data was generated, it showed a very temperate climate values, which would be helpful for the analysis of the building design. The red mark color shows the entire landscape of Collingdale town, which includes different types of places which will be discussed later. The total population of the Collingdale area is around to be 9,000 people. The five famous places found to be in Colindale are the Eden Cemetery, the Mt. Zion Memorial Cemetery, Harris Elementary School, Colindale Public Library, and St. Joseph Church. The three most streets which are used in the Colindale town are known as Macbeth Boulevard Street, Clifton Avenue Street, and Woodlawn Avenue Street. Climate data. This shows the annual results of the dry bulb temperature found in Philadelphia, wherein the lowest is found to be around -13, the highest to be around 40. The wind direction which was found to be in Philadelphia was blowing from the northwest to the southeast as shown in the diagram. The highest annual wind speed which was recorded was around 16 meter per second, while the lowest was recorded around 2 meter per second. This diagram shows the sun path of the Philadelphia, which represents the overheating periods related to the solar gain. It also represents the sun path of the month of June and December, while the yellow color, as you can say, it indicates the annual variation of the sun path.
Kinetic facade concept. Biomimicry. Beehive honeycomb structure is the design inspiration for our kinetic facade. A honeycomb structure is used as the design inspiration for the kinetic facade, which helps to reduce the amount of material used, that reduces the weight of the panel and the minimal material cost. The advantage of this design is that the panels can move in x-axis and z-axis according to the sun's movement. The triangular steel structure built to support the panels for the kinetic facade due to their stable shape. Actuated and socket joint is used to move the panel to follow the sun path. For better understanding, the following slide shows our design concept implemented on a building. Sustainable strategies. Orientation and shading. The kinetic facade must be designed south-facing of the building for maximum passive solar heat gain, to maximize winter sun exposure during winter months, to provide shading during months to achieve active thermal comfort.
Building plan. The ground floor includes 8 rooms, which are the consultation rooms, admin room, reception, waiting area, and the gym, which will be of 2 floors, while we have the entrance as well as the corridor. The first floor also consists of 8 rooms, which are the changing room, X-ray room, MRI room, lab, administration, receptionist, waiting area, and the continuation of the gym to the first floor, while we have corridor as well. This was the model for the base case. It includes the floor area of 975 meter square, wall area of 2190 meter square, and glazed area of 873 meter square. This is our optimum case model, including the kinetic facade. The kinetic facade is attached on the east, south, and west side of the model. This was the optimum case model which was used for the summer season. The south, east, and west direction were kept 45-degree open as per the suncast results. This optimum case model was used for the winter and autumn seasons. The south and east direction were kept 45-degree open, while the west direction was fully opened as per the suncast results. Building codes and envelope. 3 building codes books were used, which were the ASHRAE 90.1 for the U values, standard 55 ASHRAE for the thermal comfort values, and ISNA Lighting Handbook for the lux level values. ASHRAE standard 90.1 shows the building envelope requirements for the climate zone 4A, which comes under the Philadelphia climate, while on the right side you can see the U values as per the ASHRAE standard. As per the ASHRAE standard 55 book, the optimum temperature should be between 20 Celsius to 24 Celsius, while the IS9 Lighting Handbook provides us the maximum lux level that should be there in a gym, which includes exercising, workouts or sports or games, which are to be between 300 to 500. By following the ASHRAE standards for the U values, we kept the optimum case U value for the wall to be 0.55. The optimum case roof U value was kept at 0.206, while the optimum case window U value was kept at 2.82, again which were as per the ASHRAE standards.
IES analysis, optimum orientation and suncast. This table shows us the total system energy from January to December 2021. 270 degrees south facing is chosen as optimum orientation due to the lowest total system energy as per the table. This slide represents the suncast analysis for winter season at 1 p.m. As per the suncast, solar gain is higher on the building facing southeast compared to the building facing west. This slide represents the suncast analysis for summer season at 1 p.m. As per the suncast, solar gain is higher on the building facing southeast compared to the building facing west. This slide represents the suncast analysis for autumn season at 1 p.m. As per suncast, solar gain is higher on the building facing on southeast compared to the building facing west. This table represents the suncast analysis done for the orientation of the kinetic facade. On winter, Jan 15th, southeast facing kinetic facade at 1 p.m. is 45° and facade facing west is fully open. On summer, July 15th, southeast facing facade is 45° open and west is 45° open at 1 p.m. In autumn, October 15th, southeast facing facade 45° is it's open at 1 p.m. and west it's fully open. Similarly, the same orientation is followed at 9 a.m. and 4 p.m. for 3 seasons. Kinetic facade was not used for the north direction as it wasn't required due to very minor solar heat gain as per the suncast analysis. Thermal analysis. This table represents the air temperature values with heating and cooling off for the base and optimum case. As air temperature values were not as per comfort level for optimum case, air conditioning was switched on to generate the comfort level air temperature for optimum case. As per the table, you can see at winter it requires heating, at summer it requires cooling, at autumn it requires heating. This table represents the solar gain values for the base case and optimum case for all 3 seasons. As per the table, there is a significant reduction in the values of solar gain due to the change in building materials and orientation of the kinetic facades. This table represents the total system energy for all 3 seasons at base and optimum case. In winter and autumn, total system energy is more in optimum than base case as air conditioning was switched on to reach the comfort level air temperature.
Daylighting analysis. This represents the daylight analysis for the winter season. Upper diagram reflects the base and the optimum case results of the whole building, while the lower table reflects the base and the optimum case results of the gym room. And as you can see, there is a drastic reduction in the values of the lux levels as well as the daylight factor percentage for both the whole building as well as the gym room. This represents the daylight analysis for the summer season, and it can be seen again as there is a drastic reduction in the values of the lux levels as well as the daylight factor percentage for both the whole building as well as the gym room. This represents the daylight analysis for the autumn season, and as can be seen again, it shows a drastic reduction in the values of the lux levels as well as the daylight factor percentage for both the whole building as well as the gym room.
These images represents the radiance analysis for base case and optimum case for winter at 1 p.m. The lux values for the gym room were reduced to required range of 200 to 500. These images represent the radiance analysis for base case and optimum case for summer at 1 p.m. The lux values for gym were reduced to required range of 200 to 500. These images represents the radius analysis for base case and optimum case for autumn at 1 p.m. The lux values for gym room were reduced to required range 200 to 500. Hope you had a good time. Thank you for listening.